In this quick review video, we're going to look at a type of interest called continuously compounded interest. Okay, so what is continuously compounded interest? Well, what this is the mathematical limit that compounded interest can reach if it's calculated and reinvested in the account's balance over a theoretical infinite number of periods. So basically, every second, every millisecond of the day, your interest is earning interest. So like in the previous quick review, we looked at maybe your interest was compounded 12 times per year, so monthly. This would be a theoretically infinite number of compounds. And the formula for this is just the following. A is equal to, so A is the future amount in your account, is equal to P, so your principal, your initial value or your initial deposit, times E, and I'll show you where that is in your calculator. Okay, this is the exponential constant. E raised to the R times T power. Okay, R is the interest rate in decimal form, and T is the number of years. Okay, just like how it's been given before. All right, so let's work an example. Suppose you invest $1,000 at an annual interest rate of 5% compounded continuously. So whenever you see a problem that involves compounded continuously, you're going to use this formula. A is equal to P times E raised to the R times T power. Calculate the final amount. So this is what we want to find A. You will have in the account after 5 years. All right, so let's see what's given. You're given your principal, your initial deposit of $1,000. You're given the interest rate, which is 0.05. And T is the number of years. So I want it after 5 years. So T is 5. So we're going to take $1,000, multiply this by E raised to the 0.05 times 5. All right, we're going to need our calculator for this. So here's what we're going to do. This E, where is this in your calculator? So when you look on your TI-84 or TI-83 calculator, you should see this button called ln, stands for the natural log, and above it, you should see E raised to the X power. Okay, so here's how we're going to work this. We're going to take $1,000. We're going to multiply it. We're going to have to use our second function button to get to that part right there. And you're going to notice I'll put an E there to the exponent. So 0.05 times 5. Well, let's see how much we're going to have. Oh, not bad. We're going to have, after 5 years, $1,284.03. All right, so for this quick review, what you're looking for here is continuously compounded, and you're going to use that A is equal to the principal times E raised to the R times T power.